Hello, in this video I'm going to start looking at forces more closely. And we've already seen in dynamics that we're concerned about forces and how they change the motion of objects. So it makes sense to have a closer look at what these forces are, which forces are we going to consider, how are we going to describe them. So that's what I'm going to cover in this video and probably maybe 2 or 3 videos after this, because there's quite a lot of stuff to look at. So starting with terminology and key categorizations of what's going on with forces. First thing we need is that there has to be more than one object. You can't have a force acting on an object that's just sitting there completely on its own. All forces come in pairs. We've seen this in Newton's third law, which is to do with conservation of momentum. So they're all in equal and opposite pairs. So we have to have two objects which are exerting forces upon each other. So that's the first thing you always need to keep in mind. You don't just ever get one object with a force acting on it and nothing else around. So always keep that in mind. Then we need to think about how we can categorize our forces. So the first categorization that I'm going to make is between non-contact forces and contact forces. So if we've got two objects exerting forces on each other, well, are they touching or not is what we're saying here. There are some forces that can act at a distance where you've got two objects with a gap between them, but they're still exerting forces equal and opposite on each other. So these are our non-contact forces, whereas you've got other forces where the objects have to be touching. There needs to be an actual physical contact going on between the objects, otherwise the forces won't come into existence. Right, so specifically, what are these? Right, the non-contact forces are all what are referred to as fundamental forces. So these are forces that cannot be broken down into lower level descriptions. They're not aggregations of other effects. These are our absolutely foundational forces, of which there are 4. There's gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Now, in classical mechanics, we are only concerned with the gravitational force. The others we'll pick up in later sections. We don't have to worry about them at the moment, just be aware that they exist. And we know with the gravitational force that this acts at a distance. It's a non-contact force. If you drop out of a plane, well, you're not touching the Earth, even though it's pulling it down. The Earth is pulling you down towards it. So that is the one non-contact force that we're going to be looking at. A little bit of a clarification here on forces or interactions. Some of you, if you've read around on some of this, you might have seen these fundamental forces described as fundamental interactions. Well, that is true in some descriptions, particularly if we get into quantum mechanics for looking at electromagnetic strong and weak forces. The quantum mechanical descriptions of these phenomena are referred to as interactions. They're no longer described as being forces. And this is something that we've already been seeing in physics, that you can get different descriptions at different levels of analysis. So in classical mechanics, well, we're looking at a macroscopic level. We're concerned about forces as described by Newton's laws. So calling them fundamental forces and saying that gravity is a force is fine. That's fine in classical mechanics. Okay, it doesn't work when we get into, well, in the case of gravity, general relativity. Then we'll stop describing gravity as a force when we're in general relativity, but we haven't got there yet. We're doing classical mechanics. So, let's stick with forces. It works fine. Similarly, in quantum mechanics, when we get onto that, we'll be looking at interactions rather than forces. But at the moment, classical mechanics, forces, that's fine. So don't fret about that. Right, then we've got our contact forces. So this is where we've got, again, two objects, because we have to have pairs, and they're actually in physical contact with each other. And these are non-fundamental forces in that they are made up of lower level, more foundational phenomena. And I'll talk about that in more detail in a separate video because it's a little bit complicated and I don't want to make this video too long. But they are non-fundamental, and we'll be looking pretty much at 4 contact forces, 4 of these non-fundamental forces. So we've got the normal reaction force. So that is the reaction between any 2 objects that are touching. So you've got a ball hitting a wall, and the wall, if the ball was, going into the wall, bouncing off of it, then the wall has stopped the ball from traveling off to the right. It's exerted a force off to the left to make the ball rebound back the way it came. So that is a reaction. So that's where we get the reaction force, and it's normal in the mathematical sense, as in perpendicular. So this is a force that acts perpendicularly to the, or perpendicularly, I never know how many L's it's got in it, to the point of contact. So say we've got a ladder leaning against the wall is stopping the ladder from falling over. The point of contact that we've got at right angles to that point of contact, that surface, will have a reaction force. So that's our normal reaction force that occurs everywhere that 2 objects are touching each other. Then we've got friction that we're quite familiar with. So that's 2 objects rubbing against each other. So a book sliding across a table. We've got a surface that's rubbing together. So that's creating a force of friction. So we're happy with that. Tension. So we've got a rope or a tow bar or something connecting 2 objects. Then if this object is pulled off to the right, then the rope will transfer that force along it so that the object on the left is also pulled off to the right. So we've got a force that's acting inside that rope. It's pulling the left-hand object forwards, and it's also slowing the right-hand object down. So it's pulling the right-hand object backwards. So we need a way of dealing with tension in ropes and tow bars. But again, all of these things have to be in contact. We've seen that with all of 3 of these so far. There has to be contact between the objects. And then the final one, which we probably do the least with, is air resistance. So you've got an object falling through the air. The air is loads of atoms and molecules. So it's like jumping into a ball pit at a play park. You've got these things that you're hitting and it slows it down. So it's impacts between tiny objects and a solid object. So again, we've got impacts going on there. So it's all to do with contact. So that's our general framework of what we need to, start delving into here for forces. Pairs of objects, and then contact forces that are fundamental, non-contact forces, I should say, that are fundamental, and contact forces that are non-fundamental. So I'll delve into those in more detail in the next video.